For my project, I designed and taught a section of a college sophomore-level computer science course. There is a lot that goes into designing a college-level course, so this video highlights only a small percentage of what I created. First, I made the textbook optional, and I wrote my own reading assignments to replace it. The reading assignments are stored as quizzes in Canvas. Each is designed to include small blocks of informational text separated by exercise questions to help students apply what they learn as they read. Students see their score as soon as they submit, and they can attempt the assignment multiple times to improve their understanding. I created 25 of these micro-reading assignments to spread out over the 15-week semester. I also changed how class time was used by designing additional live coding exercises. In the recursion unit, for example, I spent a few class periods coding a solution to find all dictionary words on a Boggle game board, such as the one shown here. The students brought laptops to follow along as I wrote and talked through my code. The Boggle example uses two recursive functions: a recursive binary search function to determine if a string is a prefix of a dictionary word, and a recursive backtracking function to search through every possible path of the game board. This exercise provided the students with some insight into how they should approach Lab 4, which required them to write a recursive backtracking function to find a path through a 3D maze. Here's an example of Boggle at work, finding all the words on that board that I showed you earlier. I made only small changes to most of the labs, but Lab 9 I rewrote completely. In the lab, students create their own map implementation using a hash table. Students write their own hash functions to see how difficult it can be to write a hash function that distributes values uniformly. To test their maps, students are provided with a word counter class that breaks a file apart by words, and then uses the student's map to count the occurrences of each word, producing a file that sorts these words first by most frequent and then alphabetically. Here's some example output from 1st Nephi, or from the book of Harry Potter. These few examples give you just a small taste of my experiences in designing and teaching this computer science course.